Hello, welcome to part 2 of our global warming and climate change. If you remember in part 1 we took a look at the difference in what climate change was. Global warming is primarily the warming of the planet, and global warming, a lot of people believe humans are the cause of global warming. Climate change, though, is just a natural climatic change where what? So we're going to start out today by going a little bit further and digging into global warming and what it means. Here's a neat statistic or a neat quote I pulled from an article. What our planet could be like. When the surface temperature of the Earth should be, based on heat it radiates to space, we find the whole globe, in other words the whole Earth, should be a frozen wasteland, colder 60 degrees Fahrenheit on average. Think about that. What our planet should be like today should be about 60 degrees Fahrenheit cold. The question is, why isn't it? What's saving us from such a frigid fate? Well, can anybody think of it? Maybe you did. What's saving us from this frigid fate is our atmosphere. Now we say the atmosphere traps the Earth's radiation, in other words, the Earth's heat. And we call this planetary warmth effect. Now when we talk about the greenhouse effect, a lot of people hear the greenhouse effect and think, it's bad, it's bad. But the greenhouse effect is actually good. Without it, we would be at 60 degrees colder. So the next time someone asks you the question, is the greenhouse effect bad or good? Hopefully you're going to say, it's good. We're concerned about. It's about the greenhouse effect going beyond where it is today. What about clouds? Clouds actually play a major role in the greenhouse effect. By reflecting solar radiation away from our Earth, some clouds actually cool the planet. And, there's a lot of debate. There's one theory out there that as our planet gets warmer and warmer, there's going to be more and more moisture in the atmosphere, which is going to create more clouds, which ultimately, a lot of sunlight, a lot of solar radiation back into space, and in effect, it will actually cool our planet. And that's that climate change that everybody's talking about. I guess that's the word I want to use. A lot of people are saying, hey, look, it's just a cycle. It's going to start getting warmer, then things will happen that'll cool off the planet, and it just goes in these cycles. Others, clouds actually, typically on the coldest mornings you see no clouds. And that's because all the heat that was here during the day can leave. But the clouds actually act like a big blanket and actually trap some of the heat. So we tend to have the warmest mornings, especially in the winter, if you want to call it warm. We tend to have the warmest mornings when there's a lot of clouds out. Now, clouds and the greenhouse gases work together to create something called the global radiation budget. This radiation budget must balance itself. Now, how many of your parents have a budget? Are your budgets balanced? In other words, when your parents bring in money and then they pay their bills, their car payments, maybe their insurance payments, maybe they're paying on their house yet. If the amount of money coming in and the amount of money going out are balanced, that's a good thing. What you don't want to have happen is that you don't make a lot of money, but yet you have all these bills. If that happens, things are going to be out of balance and you're going to get into problems. Now, the Earth is much, much, much the same way. There's only so much energy reaching our planet, and there's also some energy leaving our planet. Now, right now, they're balanced. Now, that doesn't mean it's necessarily, but right now, just the right amount is coming, and just the right amount is leaving, and it creates a planet that's really good for us as humans. So solar energy reaching the Earth's surface must equal the energy leaving the planet, otherwise the oceans would eventually boil away or freeze solid. So here we look at this budget. So again, it's not necessarily 100% equal, where the amount of coming and hitting our planet is the same amount that's leaving our planet. We actually have to have more heat coming in than leaving. Otherwise, we would be at 60 degrees colder, which is what the first slide talked about. Atmosphere gets thicker and there's more greenhouse gases and more of it's trapped close to the Earth, well, we're going to get hotter. If the gases become thinner, if the atmosphere becomes thinner and more of it leaves, well, then the planet's going to get colder. And we like it right now, just the way it is. Now, scientists warn that we are currently changing the Earth's radiation balance through human actions. So that's why some scientists are concerned about global warming and they think that humans are causing it. Now, what is the greenhouse effect? Have you ever heard that term before? Have you studied it in prior grades? Well, look at this. We have a greenhouse on the top, and we're going to planet down below. Now, the sun's shining. The sun goes through the glass in the greenhouse. Now, the glass for the Earth is not really glass, but it's the atmosphere. So the energy from the sun goes through. Now, that energy heated up the Earth, it heated up the greenhouse, heated up some of the atmosphere in the greenhouse, just like it would heat up our planet, it would heat up our inner atmosphere. Now, the soil in the greenhouse is actually going to radiate some of that heat back out. And our Earth is also going to radiate some of that heat back out. Now, what the atmosphere does and what the glass does in the greenhouse, it actually allows some of it to leave, but it also traps some of it. We don't have glass. Again, we have an atmosphere, and that atmosphere will let some of the heat out, but it will also trap some of that heat, and it will save it here for us on planet Earth. So here we look at just a different version of a global radiation budget and a greenhouse effect. So again, the sun's energy, the solar radiation, will go through the atmosphere, and it will heat our planet. Now, you can see here that not all of the solar radiation makes it to the atmosphere. Some of it's reflected back out into space. And then it heats up our planet. And some of that actually escapes back out into space while our atmosphere actually traps some of it here on our planet. So that concludes part 2 of global warming. If you have any questions, make sure you ask your teacher. Thanks. Have a good day.